The sum of two non-negative numbers is 30. Find both numbers if the sum of twice the first plus the square of the second is a maximum. Ooh, this time we're looking for a maximum. Yesterday we worked on finding minimum when it came to a problem similar to this. When they're asking you to find a maximum, they're asking for the solution that satisfies the conditions they give you and the solution that satisfies the first derivative test when we optimize. The constraint is this given information. The sum of two non-negative numbers is 30. So x plus y is 30, and x and y must be greater than or equal to 0. 0 is a non-negative number. It is neither positive nor negative, so it could also be a possibility. The objective equation asks us to find a maximum when they sum, for the sum being twice the first plus the square of the second. So 2x plus y squared would be our objective equation, and we are looking for a maximum. To begin, I will solve for one of the variables in the constraint so that my objective equation is a function of one variable rather than the two that I have here, x and y. X looks like it might take less time for us to do the algebra after we plug it in, so I'm going to solve for x by subtracting y on both sides. I have written x in terms of y, so now I will substitute the equivalent expression for x into the objective function, 30 minus y. Let's do some algebraic simplification before we derive. You don't have to, but I prefer to. Now the derivative s prime with respect to y, we're deriving with respect to the variable here, y, is 0 minus 2 plus 2y. And we got that from the power rule, pop down, power down. Now we have our derivative, and we need to find our critical numbers in order to get our possible max or min values. We get critical numbers by setting our derivative equal to 0 and solving. Add 2 on both sides. 2y is equal to 2, so y equals 1. I have one of the values, so now I will use the constraint to solve for the other value, which is x. X is equal to 30 minus y, so x is equal to 30 minus, and y is 1, x is 29. Since that was our only critical number, how do we know that this is the minimum? You can either make a number line, or you can use the second derivative test for relative extrema. To use the second derivative test for relative extrema, I would need to find the sign when evaluating s prime prime of our critical number. S prime prime is the derivative of s prime, and that would be 0 plus 2 times 1, 0 plus 2. S prime prime is 2. 2 is a positive number. This indicates that at the critical number y equals 1, we're concave up, which indicates a relative minimum. So we just found the values for a relative minimum, a minimum sum. We did not find a maximum, or did we? So second derivative test tells us that the numbers we found give us a minimum. I'm going to test it out. 2 times x, which is 29, plus y squared. Will this be a maximum? It doesn't make sense that that would be a maximum. Why would we put the smallest number, a tiny number, to be squared if we're looking for a maximum sum? Wouldn't these numbers need to switch places in order for our sum to be a maximum? Let's try that. 2 times 1 plus 29. squared. The sum here is 843. 843 is definitely greater than 59. So when y equals 1 and x equals 29, we get a minimum. And we got a maximum when we switched those two values. So why do we get to just switch the x and y values? Because the constraint involved addition, and addition is commutative. Example 2, what if we have the same conditions, the same constraint, the same objective equation, but they're asking for the sum to be as large as possible? As large as possible, okay? This indicates that we may need to check, quote, endpoints, looking for absolute extrema when they're asking for as large as possible. How does that differ from before? They asked for us to find a maximum. If they ask for a maximum, that specifically needs to also be a solution for S prime. It has to be a critical number. But if we can make it as large as possible, we can look at this kind of more logically. X plus y equals 30. One of the variables is being multiplied by 2, and one of the variables is being squared. So I want to get the largest sum possible. I want to square the largest number because squaring something grows way quicker than just multiplying it by 2. Remember that x and y are non-negative, so what if x was 0 and y was 30? Would that sum be larger than a maximum that we found in the first one? Let's check. 2 times 0 plus 30 squared. 30 squared is 900. 900 is definitely larger than 843. But 900 would not be an answer unless they were asking for an absolute, as large as possible. Or if they were asking for as small as possible, then maybe we would plug in 30 for x and try 0 for y. That would not satisfy our first derivative, so it would not be a minimum or a maximum. It would be the smallest or the largest. But when it asks for a maximum or a minimum, the solution must also satisfy the first derivative test. And if you're wondering if your optimization process found you a relative minimum or relative maximum, you can either create a number line or use the second derivative test for relative extrema to determine whether the critical number has gotten you a relative minimum or relative maximum. If it's the opposite of what the question has asked you to find, all you have to do is switch the numbers, and you should get the correct answer.